software engineering and peripherals. We have more than 50 members, national associations, robot suppliers, integrators, R&D institutes, and so on. And we are the sponsor of the annual international symposium. The 50th edition is now starting in another building in at the Messe Munich today for 2 days. We are co-sponsor of the Year Award, which honors innovations of robotics which are already on the market. And we are the primary resource of robotics world data. Let me now welcome our panelists and introduce them to you. Today, we welcome representatives of major global players of the robotics industry and one of the leading global postal logistic companies and a representative of a renowned leading university committed to research in robotics and automation. So let me start with Dr. Kiyonori Inaba. He's the Director and Executive Managing Officer, General Manager, Robotics Division in Fano Corporation, Japan.
Thank you. I'm really honored to attend this meeting.
And let me welcome another big robot supplier from KUKA Industries, Germany, Stefan Lampa, the CEO. And from ABB Smith, Switzerland, Per Vegard Nerset, Group Senior Vice President. And let me welcome an expert on AI and robotics, Professor Dr. Bruno Siciliano. He is director of ICAROS, which is the Interdepartmental Center for Advances in Robotic Surgery, and he is coordinator of the Prisma Lab, which conducts projects of robotics for industry and services, mechatronics and automation, from the University Naples Federico II in Italy. He once said, "The activities that can be performed by an artificial intelligence are numerous, from customer services to call centers, while it is unlikely that robots could substitute human intelligence when peripheral bodily abilities are required." Let me further welcome from DHL Germany, one of the most important postal and logistic companies, the Vice President of the Innovations and Trend Center and Trend Research, Dr. Markus Kückelhaus. And he said, "Artificial intelligence, virtual reality, and automation are driving intelligent supply chains and transforming the future of the transforming the future of the global logistics industry." But first, before we start, we have our president, IFR president. He is coming from another big robot supplier, from Yaskawa in Japan. He is not only the IFR president, he is the representative director and chairman of the board. Welcome, Mr. Chuda, Junji Chuda. He will take over. And the moderator of the discussion, Ken Fui, moderator, editor-in-chief, innovations and trend research of VDI Nachrichten in Germany. So now I give the floor to the IFR president, Junji Chuda.
Good morning, ladies and gentlemen. I'm very happy to announce the last year's result of robotics industry. We are enjoying a huge jump last year, and we show you the numbers. This number shows that installations in each year, and last year we have grown by 29% to 381,000 units a year. And the biggest growth came from Asia But as you can see, growth are coming from all the regions. Asia, 34%, Europe by 20%, America by 22%, and all the others by 12%. And especially the growth from China is big. The growth was by 58%, and the installation base was 138,000 units last year. And last year, global market has grown by 87,000, and growth of China was 51K last year. So it represents the half of the growth, more than half of the growth came from China last year. And this is by country. In China, as we said, 58%, and South Korea, a slight decrease by 4%, minus 4%, but 40,000 units. And Japan, slight increase again to 39,000 units. And Japan has become the biggest producer of the industrial robots again, with a share of 55% of the global production in 2017. Robot sales in the USA further increased to 33,000, new record, 6% more than 2016. Germany also reached a new record number, 21,600 units, 8% more than in 2016. And these are 6th to 10th largest installation. A significant increase in Vietnam. Main drivers were electronics industry, 8,200 units, 410% more than in 2016, and considerable increase in Taiwan as well, 10,000 units, new record, plus 44%. Strong recovery in Italy, continued growth in Mexico and France. And then by the market. Automotive industry is still the biggest customer of robot industry. About 125,000 units installed in 2017, 21% more than 2016. Electronics industry grown by 27%, about 116,000 units. Almost 2/3 of the global sales went to both industries. Metal and machinery industry plus 54%, and that was 44,000 units. And we believe that the industry will grow, will keep growing. And there are two good things that are going on. Robots are beginning to get into small and medium industries. And to do so, manufacturers are making efforts. One of them is simplification. This is very critical to SMEs and then also important to large global manufacturers as well. Easy to use is another key to expand the market of industry. And then another one is a collaborative robots. Robots work with human beings. This is helping small industries to apply robots for their processes. And we are achieving to the level of easy to use robots and skillful robots. To make it the skillful robots, AI is a big driver. And another area we see the changes at the big data. Big data allowing people to better decision about factory operations. And AI also will be used for this big change toward Industry 4.0. And then today, this exhibition is, the theme of the exhibition is Robot and AI, Vision and Reality. And this will be the big driver for the industry. And thank you very much.
So now we will start our discussion on robots and AI.
Moderated this session. Looking at the photo of myself there, I think that was about 4 years ago. Back then I had red hair, and now I have gray hair, so the grayer my hair gets, the shorter it will be. I think the next time I'll be bald. The next 50 minutes, I'll talk with our illustrious guests here on the topic of robots and AI, vision and reality, and we'll talk about all aspects of that. After our discussion, you'll have 10 minutes to ask your questions. So anything that occurs to you while we're talking, keep it to the end and you can ask any of the speakers. And after that, you also have the opportunity to have one-on-one sessions with any of the people who are sitting here. Preparing for this, I looked a little bit back through our annals and saw that in the spring of this year, the Association of German Engineers, that's the association that my newspaper belongs to, did a survey on artificial intelligence among its members. They asked 900 decision makers in industry on the status and outlook for AI in industrial manufacturing. It was a little sobering what came back. We write about this all the time, and you know, as a journalist, I think it's much further advanced than it really is in industry. Coming back from the 900 decision makers, 60% of them said that today they do use AI in some form for data analysis, but that's about it. Asked what's going to happen in the future, in 5 years they said data analysis will explode. In essence, they said they will have 3 times as much data analysis using AI in 5 years' time. But the more important thing for our discussion today is that shop floor systems using speech dialogue, for example, will move from today just 5% to 38%. The main impediments that they saw to the adoption of AI is that 64% of them said their plants don't have the framework in digitalization to really use AI tools today. So, you know, if you look back, we've been writing about Industry 4.0 for 7 years, and today 64% of the plants say we still don't have it. So if that's the speed that things develop at, I hope that's not the case, but you can correct me on it in a second. Another interesting aspect that came out of that survey was that when asked, this was a German survey, when asked where are the leading companies in the development of AI, 80% said that the US are in the leading group. 55% of the Germans said that China is in the leading group, and just 30% see Germany as in the leading group, and all the other countries were behind that. So that's something else maybe that you can pick up on. This survey, you can download the results online if any of you are interested, obviously. So we're going to talk here about AI and robotics, and if you look back 6 years ago at the automatica, nobody was talking about it. 4 years ago, also very little. 2 years ago, you could see it. And today, I think it's probably the dominant single topic at the show. And this is the first question to all of you, and you can pick it up individually. What impact are developments in machine learning today having on robot capabilities?
Maybe start. So I think that obviously this will give a great benefit to the users, and I think if I try to simplify a little bit or put it into a few buckets, I would say that I think with the data and the analysis we can do with the AI and also machine learning, I think we will see smarter robots that somehow are able to operate more by themselves, be more efficient, and somehow improve the processes. I think we will get more easier robots. I think the programming piece can be taken over more self-programming and so forth. I think we will get robots and implementation of robot solutions that we can get faster by AI. And I think in the end, all this then will drive for much better flexibility for the users. So somehow both smarter, easier to use, faster to implement, and a greater flexibility to try to group it a little bit on a high level. And then, of course, there are a lot of details below each of those topics.
Yeah, if we try to go more into the details, concretize it, for instance, on the vision side, there's a lot of applications today, and if you would look into these growth numbers that was presented earlier, you would see a lot of them come from fairly simple things like material handling, moving parts. Their machine learning has already entered into a certain extent where the vision imagery is now analyzed, and a lot less programming needs to be done to move those parts. So the robot itself can actually analyze how to pick the part and how to move the part and the speed that the part should be moved in. So those are concrete practical examples where the amount of programming now is getting reduced, and then obviously, as was said earlier, it becomes easier to utilize the technology. Those are some of the few clear examples where the technology is actually being put into manufacturing and into production.
Yes. Deep learning is powerful among other machine learning. As Mr. Lam mentioned, that it's gaining a great result, especially in the image processing. So for our products, so concretely, the results have already been gained in the improvements on beam picking and failure prediction and etc. Semiconductor chip and deep learning development environments has been improved. So that's why I think that deep learning, this technology will be used in not only image processing and beam picking application, failure prediction, and etc., but also in many other fields, such as tactile sense and autonomous motion. So also, recently, many researchers are seeking for the functionality to explain the learning results by utilizing in combination with other artificial intelligence algorithms. So far, we don't know how deep learning, so other algorithms learn, but if we realize it, this information will be used for various purposes. I like to pay attention to future results.
That was the vision of the suppliers. What do the customers see?
Well, we would probably distinguish 3 different fields where we as a logistics player would see AI playing quite a role for robotics technology. The first one is navigation. We need more mobile robots, mainly, of course, inside, so indoor. You might think that's not a complex environment, but it is if things are always constantly changing. If a robot needs to decide, is this a piece of a pallet, can I drive over it or not? So there's quite a lot of intelligence needed for navigation in that field. If you think of moving outside of the 4 walls, so yard management or even last mile delivery, it becomes even more complex. So their understanding your environment becomes more and more essential, and we see AI playing quite a big role in that area. So any type of navigation, we see AI as being a great lever of bringing this forward. The second thing that we see has to do with maneuvering products or items. So understanding what type of product is it, and how can I grab it, how I can manipulate it. Also here we see with vision computing that the technology is increasing dramatically. We're testing first solutions where we look into, are pallets stackable, yes or no, using vision computing components. So understanding your environment, understanding the products that you want to manipulate is quite important for us as a logistics player. And the third one that I also see is quite important is what we say is interaction with technology. So we're actually engaging a lot of human-machine interaction, and there also it is quite important that technology, that a robot understands you. Also here, speech recognition and many other AI-driven technologies can help us to also have a better communication between a robot and people, because at least for us in logistics, we see collaborative robotics as probably the biggest driver of bringing automation technology into our warehouses and logistics sites. So those would be the three fields where I see that AI can really help to improve, to bring technology to our industry.
There's always been a lot of talk about AI and robotics, robotics and AI in the research community. And often it's the case that the two terms are seen as a sort of synonyms or like together. I mean, I've been in robotics 35 years, and like at the beginning we were working on the physical aspects, on the servo aspects for controlling our robots. And I think this growth in the field, which has evolved during the latest 35, 40 years, should not be forgotten. It's not going to be replaced totally because of the use of AI. When I was listening to the first round of opinions, as well as from the nice intro by the president of IFR, the context for AI, for deep learning, is about, for instance, vision, sensing, programming, planning. But robots are a reality in the physical world. So on one hand, we have the digital world with all the AI and deep learning and big data and all that can be gained. But if you walk across Hall B4 here in the Automatica fair, you see that what is the common denominator? I mean, I've been attending Automatica since the very first edition of 2004. And the common thread, when you go through the kind of research booths, is that everywhere is force control, which is a prerequisite for human-robot interaction. And this is because of the physical world, because physical models were derived to handle the interaction between a robot and a human. So you gain a lot by embedding all the data, all the learning capabilities. But we have brains on one hand, and we have bodies. And I think the concept of embodiment should not be forgotten. A child learns how to grasp an object by not only because of neurons, not only because of the intelligence, but the intelligence is embodied into the physical limbs. So I think robotics is one field where this merge, what can be gained from AI, gives a big plus, provided that hybrid approaches are adopted, which keenly combine the physics, the physical world, with the digital world. So this is my perspective on the research side.
And how far along is that?
How far? I think now there's been, a big leap, a big jump, because, for instance, one of the difficulties of taking force control to the shop floor, to industry, was because I remember I was speaking with my colleagues, engineers at KUKA and ABB, and they were telling me that, of course, we are the expert. We know how to tune the parameters for the force control. But the big difficulty was how to allow the technician in the shop floor to plan, to program a task involving interaction, involving force control. Now, because of the simplicity, because of the plug-and-play customizability concept. And because of all the data, the task of programming an interaction has become kind of almost intuitive, plug and play. And this is because of the merge of the introduction of AI and big data and machine learning into the physical world. But I would not, because sometimes in the media, this kind of perspective is lost. It seems that all the problems, all the the kind of down-level problems can be solved by AI. In my opinion, this is a kind of wrong perspective, because it might lead to kind of false promises, because the dynamics, the physics of the robots is different from those which pertain AI per se, like big data handling.
Looking at the projects that are coming along in your research laboratories now, what are the ones using AI that are going to impact industry most?
Logistics is one field. Logistics is perfect, but because I mean, there's been a growing interest of logistics, and also this is important because at the beginning, we know the story of, for instance, of Kiva Systems, Raffaello D'Andrea, and then they were bought by Amazon. But also we have companies in Europe. I just mentioned Swisslog, which is part of the Cook Group, in which the gain over the typical Amazon type is the fact that there are physical conveyors, and so this is for me it's a brilliant example of this merge of technology where all the techniques are keenly combined with some good mechatronics. Let me use this word, which is a kind of maybe obsolete, old-fashioned, compared to the sexy terms like deep learning. Mechatronics is considered almost as like kind of low level, but the advance in the logistic field, with DHL, has been the possibility of combining intelligent mobile, and for instance, mobile manipulation is one example where you have to coordinate all the degrees of freedom of the moving platform with the manipulator arm, and you do more than a simple AGV or a simple pallet thing. Mm-hmm. So this is just one example, since we have an end user from the logistic idea to mention that.
What about other industries?
Yeah, I think one thing is, if we're looking at the industries, I think that we will see probably a cut into that in many industries. I think today at least we see potentially, depending again a little bit what you want to solve with it, but if you're looking at maybe the efficiency piece, we see maybe more from larger customers, while I think more the simplification is also, as Judas mentioned, is maybe more linked to the new users, the SMBs. So there are maybe a little bit differently. But from my point of view, if you look at where do we see maybe the easiest or the first type of this being used more actively in the industry, I would say, as has been mentioned, around sensors, so vision, force control, where you either look at it was mentioned random bin picking, but I will also say that we see quite a lot of opportunities when it comes to inspection, quality control, in conjunction with vision. I think another area where we see it very much already today, and at least we as a company, we are offering that, is sort of anomaly detection. We use very, very frequently in sort of predictive maintenance side. And then I think the next step will be more, how do we improve the processes? So do we do inline process improvement? So you somehow correct the application as you run. And again, there are already offerings. So for instance, as a company, we have a digital atomizer, where we actually have sensors in the atomizer is what basically sprays the paint on cars and other components. And we are having sensors there that are measuring the way we spray and the feedback. And we are able to, as we spray, to improve the process. So some of that is the way we see it from our company.
On the industry side, you were asking about, we saw the growth in the electronics industry being getting close to the automotive side finally. And there we see a lot of these advances being looked at and being utilized. Autonomous guided vehicles in the clean room areas. We have tremendously difficult working environments in the clean room. And here we see the SMB companies being very, very much into how can we get those people out, how can we replace it with the autonomously guided robots that then moves, picks, assemble parts. And that obviously has to be done to a certain extent, utilizing artificial intelligence or machine learning. Are we utilizing the right forces when we assemble electronics product? When we get the quality feedback on that electronics product, can we then feed those results back into torque controls, etc. Those are things now being applied in the electronics, especially I would say upstream on the semiconductor side, where a lot of the challenges are and a lot of the opportunities are as well. If there are problems up there, obviously the whole product chain is then getting into trouble. So here we see a lot of interest in the electronic side.
Come to the topic of safety. Are there safety risks in applying machine learning to robotics?
Why would there be safety risks? I think it's the other way around. I think a robot that is more intelligent and is more smart will obviously help the operator instead of so this vision of Terminator and Arnold in the factory shop. I don't think we need to be worried about that. I think on the opposite, the robot will actually be able to assist the person and the operator in a better way by actually, when things are done wrong, say, hey, this is not the right way to do it, or you're not supposed to do it like this. So we see a lot more opportunity for improving safety and assisting the operator in order to, even for safety reasons. So I would say the opposite. It's the question is a little bit wrongly asked here, I would say. Sorry for that.
You never tell a journalist he asked the wrong question.
No, I would also like to say that I think that I fully agree with Lampa's statement that somehow it is not going to make it worse. And I think one of the reasons is that I do believe that when you give a robot a specific task, so as long as it is within that task, I also see no risk. And I thought I was going to use a very different examples to explain a little bit. If we look at today, maybe the area where we are furthest in the industries today when it comes to autonomous driving is cars. Yeah. And if you think about a car, are basically the task for the autonomous car is to go from A to B. It's not that it all of a sudden going to go to a football match or start to go to McDonald's and have a burger. That is not what the car has been done to do. And I think we will, sorry for maybe trying to simplify, but I think it's the same with the robot. If you use, if you make it autonomous and ask the robot to do a certain task, within that task, it's going to operate better. But it's not that it all of a sudden is going to decide to, go to a football match or do something else. Sorry for making a bit of a joke, but I think I agree. It is not. I don't really see the big issue.
Yeah, I would probably distinguish also navigation and manipulation again. So for navigation, I think it'll just increase safety due to the fact that we're using new technology that just warns us from, if people get in the way, that they get warned. And it's not just, robotics and the technology that they're using, but it's in general technology that we can use for that. We're testing all different types of IoT technologies to make sure that, whenever we have machines and people in a building, that we increase the safety. So I think here it's more that technology will actually help us to provide accidents and to make sure that we have more safety. If you see, some logistics sites and how fast they're driving around with forklifts, and you see that there's much more danger of doing that in a manual way than if you have controlled automation processes behind it. So I would say that definitely more increases safety that then there is a risk to it. When it comes to manipulation, yes, of course, it's also up to the forces that you're using. So, but also here, I think, I mean, in most countries we have regulations in place that take care of that. So, you know, all collaborative robots that we're using, of course, it's limited to certain forces that are being used, certain weights that are allowed to be picked up if it's not caged in. So also here, I truly believe that, you know, the existing frameworks of regulation that we have takes more control, that's not going to be an issue. Of course, if you use robotics, you can always do something wrong. If you equip a robot with a knife, of course it's going to be dangerous. So it's not just the robot itself, but it's also the peripherals that you're using. And there it's always dependent on the process and the design of it. But the technology itself, with especially all the sensing technology that is being used, I think it just increases safety than being a risk.
But to what extent, Aaron, could robots become autonomous? I remember I visited the Fanuc factory 20 years ago, and the vision then was robots building robots.
Yes, I have similar opinion. So in that case, we have worked on some artificial intelligence, such as beam picking and prediction, failure prediction. Even if failure prediction fails, it will not lead to the safety issue. And regarding beam picking, even if the robot fails to pick up workpiece, it will not lead the safety issue. However, there are some applications which include safety issues. So regarding autonomous motion, autonomous operation of the robot, there are several issues to be solved, including safety issue. So, so in the point, for example, when the robot causes an accident, so it's necessary to identify, explain the cause of the accident, so which is really similar, related to autonomous driving system. And so personally, I have some opinion that it's necessary, so beyond of the framework of one company, so to establish international framework, so to discuss the safety issue together. So it's really necessary. Then, so now we discuss artificial intelligence side. On the other hand, so in terms of hardware side, so I don't think we have any safety issue as conventional industrial robots. Since the robot is surrounded by safety fence, unlike collaborative robot. Of course, in general, so once collaborative robot can get safety international certification, it will be able to solve these issues as well.
So is the consensus then that the standards today are sufficient, that there is no requirement for further standards?
But so at the same time, we need to consider the robot system as a robot system safety, including profile equipment such as hand. So hand has some dangerous part, we need to care about it.
Yeah, I'd like to add perhaps, I mean, to my view, it's like safety, I mean, how do we judge whether robot A is safer than robot B? And I mean, I think it's the quantitative analysis of safety should not be separated from the issue of dependability. I mean, it's not only I mean this is like the Asimov's law that robots should not injure a human, and okay, that's fine. Now we have the new technology like the lightweight. We have sensors in the torque, in the joints. Then we have also force sensor, and we have all kind of vision and kinet sensors. So we can definitely make robots safe. But how dependable are they? You know, in the sense that you know how an application could be kind of developed in a kind of intuitive way, guaranteeing safety. And for instance, I mean, one of the discussion at the research level is that of benchmarking. because I mean, if you, I mean, cobot is a very hype word. Is a cool word. Everybody is claiming that. Every company, you know, just this is my research perspective. Every company is claiming that they have a real cobot, you know. But to have a safe and dependable cooperative robot, it's not only the fact that you eliminated the fence and the worker works close with the robot. So, I mean, I think as in terms of the research community, we still have to work hard in making our safe robots to become dependable and also to develop, as you were saying, standards and to do benchmarking. Otherwise, you know, how can we judge? And I mean, the first standard, the first ISO standard for safety was, I think it was drafted only maybe 3 or 4 years ago. And whereas this technology was around in the research labs since, I think, 20 years. So one of the first projects I was involved with DLR and KUKA is the France project, which is, I think, now 15 years old. And, you know, with all the technology, the lightweight and the sensing. So in a way, I think we really need now to take physical human-robot interaction to a level where safety and dependability they have to be clearly quantified.
Maybe comment, I would say, now we're talking safety, and I don't want to necessarily put that one-to-one as equal to the connection to AI.
Yes.
So I would like to separate the safety piece. And I do think, actually, I'm not so sure I fully share your view that we have solved the safety standards. I see weaknesses in the current safety standard, actually quite a lot. And if you really take it to the full extent, the drafted standards where some are dependent on where a robot hits you at the body, you can be hit at different forces.
Definitely.
As a responsible person for a company that deliver robots, I take that not so easy. And how can I know that a robot, if it is set to hit me at the chest level, and that I don't take my head down, and that it will hit me in the head instead. So some of those safety standards, I think they are difficult to follow. Then you can say that for every cell we are implementing, there is of course the need for a cell approval in addition. So there are of course in addition, but if you just look at the safety standard as written today, I would claim that we have some room for improvement.
So what still needs to be done? Where?
No, I think they need to be thought through and maybe defined in a different way than I've been done today. But we have also academia here today, so it's.
I try to be provocative. Yeah. If there is an accident in a factory because of a robot, it makes to the news. You know, like maybe one worker was injured, one worker was killed. Now we are talking, and since you mentioned cars, how many people are being killed now in this precise moment because of a car accident? And everybody is comfortable without reading the instruction manual to drive the car, and everybody feels comfortable. And I mean, this is the wrong perception. And this is, I mean, I got really upset like 2 years ago at the World Economic Forum in Davos. I was there, and it was this big statement: robots as job killers. You know, 5 million jobs will. I mean, come on. I mean, just is like, I think we need this technology. We need safer cars, and we need aids to the driver to reduce the number of accidents. And then, so what's the fuss about the fact that there is one accident in one factory because of a robot? Is this because it's a job killer? No, it's not.
No, and I must agree with you, Professor Siciliano. The safety, when you look at the safety standards of factories after introduction of robotics, it is a lot better. So you know, I always talk about the 3Ds, you know, the dirty, the dull, and the dangerous jobs. Yes. And as soon as you make the conversion from a more of a 3D situation into a robotized environment, you improve safety tremendously. You increase the level of the knowledge of the workers in there, you get them trained, you get them even aware of safety, because you start talking about safety in a different way. So all of a sudden you escalate the safety awareness, and the safety, I mean, the statistics are clear. So I fully agree with you on that statement. But the press sometimes likes to make, obviously, the statements because it makes good headlines. How unfortunate they are, and obviously we need to continuously learn from the accidents that are there. But every time we jump into it, there is typically an overbridge of the safety instruction and the training that has caused the accident. It's never due to the technology itself, which goes back again to, hey, how can machine learning help the operator not to overbridge safety instructions and safety devices by telling the operator, no, you're not allowed to do that, and I'm going to stop now, for instance.
I think always artificial intelligence has some uncertainty. So that's why for online application, we need to think about how uncertainty is limited. I think, so in order to realize it, there are two keywords. First one is stability, and the other one is monotonic convergence. So I worked on a learning robot, which enables robot to move faster and faster every time the robot learns the same path. So without vibration, the stability guarantees that finally the robot can move smoothly. But we don't guarantee any motion in transition. But monotonic convergence guarantees that every time robot can move smoother. So that's the difficult thing. So if we guarantee only stability, in that case, in transition, robot moves in a totally expected way. So for deep learning, so if we are going to expand it application, so we need to think about this issue. So still there are so many things to be researched in academic area, I think.
You've both mentioned this now, but what would be the impact of intelligent robots on jobs, employees, and on the workers themselves?
Obviously, there is a transformation of what the job is all about. Is the job all about a manual labor where you are actually utilizing your arms and body in a different way? Or is it more about how do you analyze what's happening with the process, how do you improve it? Obviously, there is a conversion there. The conversion from one job style, which I think we all want to get rid of, and I get this question, many times every year, and I always go back and I always ask people, what do you like your children to work with? I know I don't want my children work in manual factories. Do I want them to work with robots in factories? Absolutely, anytime, I'll sign for that. Unfortunately, they are not deciding to become engineers, which I try to make them do, but I would not want them to become manual labor in manual factories. Those days are over. We have a transition over the coming 20 to 30 years to go from that manual labor into an automated labor where people are doing a lot more with their brain together with the body. So it's a better job and it's a better life, and that conversion will happen. And it happened in many other industries. The thing is, it's not going to be a disruption. It's not going to be mass employment. We are today at peak labor. So that means every year from now on, most countries are seeing less availability of labor. So this conversion is very much in synchrony with the world development as a whole. So this is a part of improving, I would say, working lives for people.
I mean, in logistics, we have a labor shortage anyway. So if you look at the booming e-commerce, if you see what people are buying online and also the weights and the sizes of stuff we need to move around, everybody's happy if technology is helping to do that. And if it's not, I mean, with the existing workforce, we can't even cope with the rising demand that we have in logistics. That is within the four walls, outside the four walls. I mean, try to find truck drivers nowadays in Germany. It's very difficult. So we have just a different challenge right now in our industry, and there we see robotics and automation really be, helpful to also take away more the strenuous part. And I think, yes, it's going to be a transition. If I look at our warehouses, there's still many tasks that will be manually done. Also, it's an industry that is not highly automated. Unlike other industries, like a car manufacturer, you will see many robots. In a typical logistics sites, you don't see that much automation technology. But I see that, doing the more difficult parts, so identifying maybe an object, picking it, grabbing it, putting it somewhere, that's something that might be still done by people. But then carrying it around, going through the aisles and doing 32 kilometers a day through a warehouse, that is something where I believe that, technology can help. So a follow me bot and things like that, where people and machines can work side by side, I believe that will just help us and not, so it's more helping us with the issues that we see in our industry than a risk that we're currently facing.
And it's clear. I mean, I talked to some of your peers there in the e-commerce side, textile on the textile side especially, where they see an extreme amount of labor need on shorter terms. In front of Christmas, those kind of times of the year, where all of a sudden 30,000 people needs to be brought in, and 2 months later it's down to 5,000. And the working condition and the working style in those, this is not a permanent job where you develop and you actually thrive. So those jobs needs to go away. And the technology you're mentioning there, for instance, moving things around in those warehouses is absolutely something that now technology can solve. And now we just need to bring the right ROI, the return of investment, so that you can actually employ it in a greater number.
For instance, since last year, we are in a project which I coordinate. It's a project of taking robotics in logistics in retail stores. Now, of course, you click and then you can order an item with Amazon Prime, and in 1 day it's delivered, and there is all the chain, but the customers also have the physical pleasure of going shopping and touching the items. So, I mean, this clearly shows that it's not only that we will not lose in the age of globalization, of internet, of e-commerce. Still, the humans have the physical perception and, let me say, pleasure of doing physical actions. And that's why, for instance, in this project, one of the end user is quite well known in Germany's Drogerie market, DM. And so we went to the warehouse in Köln, and we just spoke with the workers. And of course, they are concerned because, for instance, in the supermarkets, in the retail stores, some of the physical jobs of depalletizing from the back room and refilling the shelves are also, involve some kind of tiredness, and the workers get tired. So we have to introduce our robotics and logistic technology, both in the back room, in the warehouses, and along the shelves in the retail stores. So if you go to internet, you find some robotized scanning units just to replace the items. Why not also to have some kind of mobile manipulator assisting the clerks and just accompanying the customers in the store? So this is one example, in my view, in which this will be a kind of seamless introduction of robotics technology, of robots among the humans, in a real context.
That's one example of how to get better acceptance.
Exactly.
But I think that's a major problem. The perception in the public is that robotics, automation, and artificial intelligence are job killers. The media writes about it all the time. I'm sure there's a consensus here that is not the case. And but what do governments and companies need to do to create better acceptance? How can you do that?
The statistics somehow, and we discussed it a little bit before the meeting started today, that obviously there are media writes and politicians write about that robot kills jobs, but all statistics, and when we talk to customers, I would say 99% of the customers I talk to, they will tell me, our biggest problem, we do not find enough people to do the job. To produce what we as consumers want to buy. So, and I do believe that with the artificial intelligence, we will just continue to find good ways for robots to taking on the Ds, whether we are using 3 or 5 Ds, the difficult jobs and the dangerous jobs, and we will continue to create jobs, different jobs. So my colleagues have spoken about the transition, and I think that's what will take place.
I have different story in Japan. So in Japan also in 1980s, so of course there were so many opposing opinion, robot deprives human employments. On the other hand, in 1980s, even it was appreciated to release the people from 3D dangerous, dirty, dull job from people. So then the robotization was expanded at once. So as a result, economic scale in Japan has grown larger than in 1980s. Then the employment has also increased. So recently, so the point is that everybody mentioned, the lack of personnel is rather worried about. So I feel personally the situation was a little changed before. So just personal opinion.
You were mentioning governments, politicians, and here I think they need to get trained on this topic. They are not living in the world of the future. They are living in the world of the past. You know, we have populism going around the world in quite big numbers, and I think this is another area of kind of a light populism. Here we need politicians that actually dare to talk about how should the industry look in the future, and how can they incentivize, especially the SMEs, which have the hardest access to this. Big companies will always sort things out. The big giants have no problem with this, but the SMEs to survive needs to get support, and here the governments and the politicians can really play a key role. And what's in it for them? What's in it for them is that with new technologies, the possibility to manufacture geographically where you want to is all of a sudden possible. You do not need to go to low-cost manufacturing anymore. You don't need to go to sweatshops anymore. You can actually manufacture close to your consumer or within the country where that product needs to be used. And that's an opportunity, and that's something the politicians and government needs to seize on. And technology is there, so I would really call for politicians to actually look into the future and leave this light populism instead.
But what can you do as companies to help human appreciation, or to develop the human competence to work with self-learning machines?
No, I think you're absolutely right. We also have a big job to do, and I think we've been a little bit afraid of speaking up about this. IFR is obviously doing a great job on it, but I think we need to do more, and as companies we need to do more to inform the public and the companies, and be a little bit more transparent in the press in regards to all the benefits that automation and robotized automation actually brings. And here I think we've been a little bit afraid, so that being a little bit too defensive. So we need to go on the offensive for the future, for sure.
I think you need to make sure that the topic is seen positive in a way that, technology and people can interact, and there's a communication between people and the machine. So whenever we use collaborative robots, a person needs to clearly understand what is the robot currently doing, and there needs to be a clear communication between the robot and the person. It could be just, okay, it's a green light for when I'm driving. It's a nice face when he's understanding you. So things like that. It's more making the robot a nicer thing than maybe some images we have from the past where it's dangerous, where it's where it just has a negative perception also from people. And we, whenever we try to implement solutions like that, we always ask people also when it comes to the acceptance, the social acceptance of those technologies. Maybe we also need to be aware of sometimes not overhyping certain technologies. I mean, we had probably the biggest hype when it comes to bringing technology into logistics with the topic of drones. So everybody was really hyped about drones. I think also here maybe it would be better to be, to bring across more a realistic picture of where it's mainly useful, where it's mainly helpful, where it brings the main benefits instead of sometimes maybe, being hyped by technology and pushing that outside, and also the media happily picking that up. So I think staying realistic, being modest about it, I think that also helps.
I think obviously we have a task to do as an industry to try to convince them, of course, inform about it, but we will always be seen as, or we will always struggle to be seen as objective as robot suppliers in this discussion. So I think what is very helpful when as Kuklaus is saying, when users of robot, not the producers of the robot, but when users of robot saying that they are not able to find truck drivers, they are not able to find people to fulfill their needs in their warehouses. That, of course, is important. That also comes to politicians and to media, because that will really help. We will always be seen as a little bit subjective in this topic, and that is one of the challenges we have.
Okay, as a last question for each of you, look ahead to Automatica in 4 years' time, 2021 or 2023 or whenever. And tell me, what's the most impressive AI application that will be shown here at the show?
Well, you will see KUKA robots being mass deployed, autonomously navigating in factories, doing manufacturing. This will be really then something that is widely used, and we will display that. We obviously displayed it over a number of years, and we found the first cases. We mass deploy it. 2021, you will see that being a mainstream technology that is massively utilized.
I would like to see, and I hope that we will be able to show that. I would like to see robots being able to be utilized by humans with zero pre-competence on the uses of robots. So basically, as easy to use as a smartphone today, where you can give it to a 3 or 4 year old person without no training, no manual, and they are going to be able to use them efficiently in their production.
In 4 years?
That's what I would like to see.
So, in my case, I think the application for human interaction is the most important application in my understanding. So everything, so machine and robot, of course, including human operator, are connected through networks. In that case, collaborative robot, which doesn't require a fence, will be able to move themselves. The point is, so the robot needs to judge where he is going. So in order to judge, so robot needs the information, surrounding the information, so which can be got by IoT technology. At the same time, so after getting information, he needs to judge. So he needs the information, judge the information based on artificial intelligence. Everything is connected. So currently, robot is waiting for works. For example, workpiece is going to the robot place. But in next generation, robot moves to the task point by themselves. That will be a totally different point, so I feel.
What does the customer see?
I mean, we see already today robots driving to wherever, picking location where we need to pick stuff. I would like to see robots in 4 years that understand better, what type of products they have in front of them. So understanding what's the size of the products, what the weight of the products, how do I actually manipulate that? There I still see a lot of challenges. So the navigation part, we see very promising solutions already today. The manipulation part, so thinking of, okay, you have a container full of parcels and have a unloading robot that understands exactly, what type of product is it and how can I unload that. That would be something I would be hoping for.
And the visionary?
I agree with Per Vegard, what he was saying, that I don't know if it's going to happen in 4 years to have this kind of plug and play, that you see a robot and same way as with the smartphone, with the tablet, with the phablet. But I think what I've noticed, I've had the privilege of attending all the editions of Automatica. I think I've noticed that in the recent years, there are more kids, more youngsters, more students. And I think this is very important because some of the jobs in 20 years from now do not yet exist for our children. You clearly mentioned, I also didn't succeed in I have 3 kids. The 2 boys, they didn't want to do engineering because they thought it was kind of boring and too tough to study. So they're both in economics and management, of course. It's like, I don't know about my daughter yet, but it's like, anyway. So going back, I think that's very important because the digital natives, I think, will have a big chance to change the world. And I think, I think a place like this, Automatica, should really involve and take more kids, more students to visit the fair, because I think this will give a big contribution towards what the impact of this technology will have on our social life. And so probably, I don't know if in 4 years we can have like plug and play, but that's the thing to do. But I think a contribution towards that would come from our kids, really.
It's a good ending to the open discussion. I'll turn it over to your questions now, if you have any. Raise your hand and you'll get a microphone. If you could please say your name, where you come from, so that the people in the live stream can follow you.
I would like to ask Yunji Chuta to come also forward, because he can also answer the questions, because he presented the figures, and I'm also able.
Hi, my name is Thierry Pigot. I'm working for a French magazine called J'Automatise. It's about automation. I have 2 remarks about things that I've told by Professor Siciliano. Excuse me if I'm not... First, you've mentioned that the press is always reporting reporting when there is a kill or accident with machines, and you've said that we're more soft on car accidents, except when it's a fully automated car accident.
Tesla, yeah, of course.
Yeah. Why? My remark is this: we don't accept the fate when it's coming from something which is unhuman. We accept it when it's among us in some kind of... that's something which is more philosophical than anything with technology. We don't accept the fate when it's a natural hazard on the same way. Yeah. And we consider that we can change us by talking, by making rules and etc. But we don't have... That's a point of view. I want your... answer of all of you about this. And some things about the jobs killing. We can't make at an affordable price today a car if we don't put robots, and huge number of robots in a car building factory. We all know that. That's simple. If we make it by hand, the price of the car would be, I don't know, 50 times, 100 times, 200 times more expensive. We all know that, but in the car industry, we have in some way shared the growth of the revenue between people. There is less people working in it. And the problem is that the diffusion of robotics today and all the technology like collaborative robots which change things, we will have to learn how to share the growth revenue. It's my point of view, perhaps. And if you have a reaction about this.
Okay, can I stop you there? There are very many questions. Please keep the questions and the answers short, because there are a lot of questions.
Should I?
Yeah.
Try. No. I mean, just the issue you mentioned about that it makes the news. I mean, in research, in robotic research, there is a whole area which is identified now as roboethics. And roboethics concerns with the ethical, legal, and societal issues of introducing robotic technology in our life, in our society. So I totally agree. You know, of course, I mean, we have humans and we have machines, and both humans and machines can make mistakes. You know, just as like I think we should really go over the kind of let's say common sense that okay, we don't accept the machine to make a mistake because you know you can have like some kind of natural hazards, but the thing is that if you have you can have like for instance a semi-autonomous car in which it's not totally the fully autonomous car. And then you have to accept that the mistake. I mean, at the end of the day, it doesn't. I don't think it makes a big difference whether the mistake is made by the human or by the machine. And as far as we can address what is the legal and societal impact of a mistake. And the other question you had is about
Skill.
About
Skills.
skill.
Yeah.
Yeah, I mean, like, for instance, you mentioned the automobile, but, I mean, we have a lot of robots. Automotive is #1 market. But now, for instance, we have wearable robots. Robots that can be worn by the workers, and they can work. No. Some of the operations on a car are still manual. So why, I mean, there are the big companies like, I gave a keynote talk for the convention of Hyundai, Korean company, and they are developing exoskeletons. And so is the case for Toyota. And yesterday there was a presentation by Comau of the exoskeleton. Probably some of you were there. And we can also improve the work from an ergonomic viewpoint. So this is one case in which you cannot fully replace the human worker with the robot, but the worker can wear an exoskeleton and can operate in a more kind of ergonomically friendly way to do the work. So this is one example in which I think it's a positive introduction of technology, which is not replacing the human. It's really accompanying, it's assisting the human as an aid.
Can we take the next question, Frank?
You mentioned earlier that simplification and standardization were two of the drivers propelling growth. But from my point of view, I see simplification, but not standardization. And every AMR, AGV has a different plug, a different charging method. Every wearable has a different charging method. Where's the standardization?
Yeah, sorry. That was my presentation, so I have to answer the answer. I have to answer. Actually, standardization is a far away, in reality, but like we can do, say, I mean, on the background, it can be different, but at a human-machine interface, it can be very similar eventually, like we use smartphones. So there can be some way to get there, but say, as you mentioned, that maybe background software, that there are so many existing robots, so we cannot unify everything. But at least my machine interface can be close enough for that people can easily handle. That's what we wanted to say. We simplify the description, sorry.
The next question at the back.
Yes, okay, I'm Tord Scheck from Aktuell Produktion in Sweden. A question about collaborative robots, definition of collaborative robots, lightweight robots, real robots against not real robots, which is actually a discussion taking place. Collaborative applications I can understand, and I think we have players here that also claim that any robot can be collaborative, depending on the, let's say, system around the robot. So is there a confusion, you think, in the marketplace of collaborative robots?
Per?
Yeah. So I would say I think there is, it may be dangerous to say there's a confusion, but I think that if you would ask 10 different people what, for a definition of a collaborative robots, I think you will get multiple answers back on what a collaborative robot is. I think some will claim it is a robot that really work together on the same assembly piece, which is sort of one type of robot. And we as a company happen to have a human robot that are able to do so. But there are also a lot of robots today that are, I would call, more as the coexistence on the shop floor. So there are sporadic interaction while the robot in general are working by itself, but you just maybe would like to sort of get rid of the fence. And then I know some people think about collaborative robots as an easy-to-use robot. Some think about collaborative robots as lightweight compared to maybe the traditional ones. So yes, I think there is a, and when I earlier said that there is a need for maybe improving the safety standards, that's actually one of the areas where I think we need to go, where we don't just say cobots, and we include all of those topics we discussed, but we need to probably go and segment the cobot market or cobot type of robots a little bit more, and then have specific safety standards for those different type of robots we mean.
Yeah. May I? Sure. So IFR is in charge of making statistics of all those cobots as well. So we try to define the cobots. One definition is by ISO standard, but that's very few numbers are there. But there are many robots intended to be used as a cobot, but that's not defined. It's not defined by ISO. But and then another thing is that robots are being used in the system as a cobot, but robot was not developed to be cobot itself. So there are many definitions so far. So IFR is working diligently together with manufacturers and end users how to define those cobots and how to make statistics out of those.
There are two further questions, I think. Second row.
Holger Röhr from the German magazine Automationspraxis. So you've been talking about the acceptance of artificial intelligence in production. My question is, don't you think that applications in the consumer field will be a driving force to rise this application like Alexa or whatever, that it's more coming from consumer applications actually?
Well, consumer application makes artificial intelligence or machine learning affordable because of the scale effect that we get from there. And obviously the usage of it is key, because you get users, we talked about children, younger users obviously require these kind of technologies when they move into manufacturing. But the key thing still is that a lot of manufacturers do not allow us to connect the robots. So we need to have connected automation and connected robots to actually make this artificial intelligence or machine learning really happen. So connected robots is the #1 thing. But yeah, affordability comes from the consumer side. Usage on the consumer side comes into the factory because younger users says, how can we utilize manufacturing in this way? It's very old-fashioned, disconnected. So those two things obviously come from consumer side.
Maybe one quick comment. I think it is also interesting, the whole definition of robots, because I think this is also one of the reasons why I think a lot of the debate about robot kills jobs and so is also coming, because there are not very many definitions of a robot today that we call Alexa robot. But I know in many people's view, it is. I mean, it is basically a simple computer, and it's not a robot. But I know many people call it a robot. So that is also part of the confusion in if robot kills job or where do you use it.
Question in the front row.
Martin Schupek, VDI Nachrichten. We discussed the role of the robot builders and the users, but I haven't heard any position of a supplier, for example, for end effectors, so as grippers. And what's their position where do you see them in building solutions for artificial intelligence?
Now, obviously, and here we get back to what Professor Cicilline was talking about. Grippers are key, especially in cobot side and artificial intelligence or machine learning, with the combination of force control. And this is maybe one of the things that has made that the growth numbers aren't as fast as we have predicted, because the peripheral equipment hasn't been fully adapted to it, and it's very much the force control part of the gripper side that needs to come into place, and that happens now, because then the whole equation is actually complete. The robot is already there, the gripper that grips the part, and all of a sudden is also adapted to it, and that whole chain then can be applied into a cobot and machine learning situation.
If I may add, on the research side, I think the technology of manipulator arms can be compared to the technology of the human, in the sense that, you know, what we can, I think we have almost reached, you know, the skills of human. It's not the same story for, as you keenly said, for the end effectors, the grippers, because of a number of reasons, of course, we have companies. One of the leading company is Schunk in Laufen for the grippers, you know, just as like, and we have in our lab, we have 2 anthropomorphic 5-finger hand. Every 2 months, we have to send them back because they are fragile. And even though those hands have only 9 motors, it's, I mean, they are very expensive, and they're not on the shop floor yet. So in the research community, there's been a new trend about adopting a minimalism principle. And this is inspired by neurosciences. Why is that? Because when we grasp an object, we don't, I mean, from a neural viewpoint, we don't control all the 20+ degrees of freedom of our fingers and phalanges, but actually there's been a study by a famous neuroscientist, Marco Santello, an Italian at the University of Arizona, that we learn how to grasp objects according to the concept of postural synergies. So basically there are 3 basic motions that, you know, with kind of grasping an object, doing this other motion, and then this fine motion. So now some companies are revisiting the design of the hands. So what we did, other than trying, I'm a control guy, other than trying to control the 20+ degrees of freedom, forget. Maybe we can control these 3 basic motions. So why not to redesign the hands, also at the benefit of compactness, and also try to have a minimalist hand only with 1 motor, 2 motors, 3 motors. So you can, this is one example in which you can learn, I mean, and robotics, I mean, from a research side, I can tell you, any further progress in robotics will not be in this room, in the room of the experts. Any further progress would be at the crossroads with other fields. Robotics is really living this kind of contamination, in the sense that we need inspiration from other disciplines. And this example of the effectors of the hands is one such thing in which we can completely revisit the design of the hand and adopting some kind of single motor, 2 motors hands. And then you can have a keen design with tendons and cables to get all the degrees of freedom that you need. But we are not there yet.
Okay, we're 10 minutes over time. One further question. And
thank you. My name is Uwe Haas. I'm a consultant here in Munich. I have actually 2 questions, I'm sorry. The first one is about the definitions of robots. It's more a question to IFR. When is the separation of industrial robots and service robots disappearing? That's the first question. And the second one is about bottlenecks of innovation. This connects to Professor Siciliano's talk about using cognitive experience from the humans into the design of robots. Where are the bottlenecks? We mentioned standardization. I assume research needs to be done, but are there any other bottlenecks for bringing AI and robotics together? Thank you.
Yeah, that's okay. So when it comes to definition, IFR does not really define the category of robots, but there are standards by ISO or IEEE to define the robots, and without definition, we cannot discuss deeply about what we have to do with those robots. So the definition will not be gone. That's my answer.
I can't provide the definitions we have.
And the second question?
On the second question, I would say one of the key things is the crossover, and you were referring to that, between different skills. This is the bottleneck. At least from a robot company standpoint, we are too many robotists within the robot company, and we need to cross over with other skill sets. And those skill sets doesn't need to come necessarily from the engineering community. They need to come from other communities. And in that crossroad, that's where innovation will come. And it's not going to be a disrupted innovation, but it will be continuous good innovation that will drive easy to use, and it will drive new ways of doing things to simplify, not complicate things, which sometimes the robotists tend to do.
And maybe one, if I'm allowed, I think there is of course the need for kind of deep learning, artificial intelligence competence. Personally, I believe that over time this is going to be off the shelf, partly competence that you will get or you can buy easily. I think it is the crossroad also with understanding the application. Still the robot or the solution are still going to actually perform a task, whether that is to weld something, is to pick something, to empty a container. And I think having the combination of those skills will be very important.
Okay, I think we should end it here because people want to talk to you individually as well, and we're 10 minutes over time. Thank you all for taking part. I look forward to seeing you again in 2 years' time.
Thank you very much.
Yeah.
Thank you also from my side. You have now. Thank you very much to all the panelists. It was a very lively and interesting discussion.